All right, ready to dive into some seriously mind-bending stuff? We're talking dark matter and dark energy, the invisible forces that seem to rule the universe. It always blows my mind that we can barely see a fraction of what's actually out there.
It really puts things in perspective, doesn't it? Like we've been looking at the universe through a tiny keyhole all this time.
Exactly. And today, we've got three incredible books as our guides: Dark Matter and Dark Energy by Brian Clegg, Einstein's Telescope by Evelyn Gates, and The 4% Universe by Richard Panik. Each one tells a different piece of the puzzle.
And when you put them all together, you start to see the bigger picture of how these invisible forces shape everything around us.
Okay, so where do we even begin with a topic this massive? Well, Panik's book tells this really fascinating story about a discovery, something seemingly random that completely changed how we understand the universe.
He's talking about the cosmic microwave background radiation, right? That faint afterglow from the Big Bang.
Bingo. But the story behind it is wild. Picture this: two scientists, a giant antenna, and a whole lot of, well, you'll see.
It's a great example of how some of the biggest breakthroughs happen completely by chance. We're talking 1965. Arno Penzias and Robert Wilson are at Bell Labs working with this massive antenna originally built to pick up satellite signals.
Okay, so we've got this huge antenna pointed at the sky. And instead of hearing signals from space, all they get is this annoying hiss. Can you imagine?
It gets worse. Clegg talks about how they actually thought it was bird droppings interfering with the equipment. Imagine thinking you stumbled onto something groundbreaking only to find out it's just pigeons.
That's hilarious. But in all seriousness, this hiss turned out to be the echo of the Big Bang, the leftover radiation from the universe's birth. A discovery that basically confirmed the Big Bang theory, which was still being debated back then.
It was a game changer. This accidental discovery completely transformed cosmology, turning it into a whole new ballgame. And it secretly paved the way for all the research into dark matter and dark energy, though they didn't know it yet.
So we've got this accidental discovery, confirms the Big Bang, and sets the stage for even bigger questions about the universe. But where does dark matter actually come into play? Where do things start to not make sense?
Well, it all began with astronomers looking at how galaxies rotate. They thought they had it all figured out. Stars should move based on the gravity of all the stuff we can see, like stars and gas and dust.
Right, kind of like planets orbiting a star. The closer they are, the faster they go. Basic physics, right?
Exactly. But when they actually measured the speed of stars in these spiral galaxies, something was off. The stars on the outer edges were moving way too fast.
Too fast, like they were breaking the rules of physics.
It seemed like it. It was as if there was some extra gravity holding these galaxies together, something we couldn't see, but had to be there because of its effect.
And that's where dark matter enters the scene, this invisible stuff that's pulling the strings.
You got it. It became this cosmic mystery. Astronomers saw the effect, these weirdly rotating galaxies, and they had to figure out what unseen culprit was causing it.
Like a cosmic game of Clue, but instead of Colonel Mustard in the library, it's dark matter in the dot well, dot everywhere. It's amazing to think something invisible can be so powerful.
The 4% universe talks about Vera Rubin, a real pioneer in this field. She really solidified the case for dark matter with all her observations of galaxy rotation in the 70s.
So she's like the Sherlock Holmes of dark matter, piecing together the clues and revealing this hidden world.
Exactly. And what they found was mind-blowing. Dark matter isn't just some weird exception to the rule, it's everywhere. It's estimated to make up a whopping 85% of all the matter in the universe.
85%. So everything we see, all the stars, planets, galaxies, it's just a tiny sliver of what's really out there.
Well, it's kind of terrifying when you think about
It
it.
really makes you realize how much more there is to discover out there.
So we've got this invisible matter, this dark matter, holding galaxies together. But the story doesn't end there, does it? Things get even weirder.
You're talking about dark energy now, right? That's where things really get interesting. Right. It's like just when you thought you were wrapping your head around invisible matter, then along comes this invisible force pushing everything apart. Panek really digs into this in the 4% universe. By the 1990s, astronomers were trying to nail down how fast the universe was expanding, whether it was slowing down like everyone expected.
Makes sense, right? Gravity should be putting the brakes on the expansion from the Big Bang.
Totally. But two separate groups of astronomers using these exploding stars called Type Ia supernovae to measure distances across the universe, well, they found something totally unexpected.
Those supernovae are pretty handy tools, by the way. Gates talks about them in Einstein's telescope. They basically explode with the same brightness, so they act like these cosmic mile markers.
So these mile markers were telling a very different story than we expected.
Yeah, they found that these really distant supernovae were dimmer than they should be if the universe's expansion was slowing down. The crazy thing is, it wasn't slowing down at all. It was speeding up.
Like hitting the gas pedal in the universe? How do you even explain that?
That's where dark energy comes in. Scientists had to come up with something to explain this acceleration, something counteracting gravity, pushing everything apart.
And that something makes up a huge chunk of the universe, right?
Yeah.
Like more than everything we can actually see combined.
Way more. It's wild. Dark energy is estimated to make up something like 70% of the universe. Dark matter is another 25%, leaving, what, 5% for everything we know and love? Stars, planets, the whole shebang. We're practically a cosmic afterthought.
It really makes you feel small, doesn't it? So how do we even begin to study something we can't see, can't touch, barely even understand? What are scientists doing to try and get a handle on these invisible forces driving everything?
Well, it's tricky. It's like trying to study the wind without being able to see it. Gates talks about a technique called gravitational lensing. Basically, you use the gravity of really massive objects like huge galaxies to bend light. They act like giant magnifying glasses.
So we're using the universe itself as a telescope. That's pretty ingenious.
Exactly. By looking at how the light bends around these massive objects, we can map out where both the visible and dark matter is lurking.
So even though we can't see it directly, we can see its effects, its fingerprints on the universe around it. What about dark energy? Any cool ways to study that?
Well, Clegg talks about how the Large Hadron Collider, that giant particle accelerator, might actually be able to create and detect dark matter particles.
So by smashing things together really, really hard, we might be able to make some dark matter.
It's a long shot, but that's the idea. Though detecting them is a whole other can of worms. They don't interact with light or anything like that, so they're pretty much invisible to our instruments.
Like trying to catch a shadow, I imagine. But there must be other ways, right?
There's actually a lot we can learn from that cosmic microwave background radiation we talked about earlier, that echo of the Big Bang. Studying the tiny fluctuations in that radiation can actually tell us a lot about the early universe, including the roles of dark matter and dark energy.
So it's not just about looking for these things directly, it's about understanding their influence on the universe's whole history, right from the very beginning.
Exactly. It's like trying to understand a painting by studying the brushstrokes, the layers of paint. It all adds up to the bigger picture.
Okay, so we've got these methods, but are there any totally out there theories about what dark matter and dark energy actually are? Anything that really stretches the imagination?
Well, there are some physicists who think that instead of adding new things like dark matter and dark energy, maybe we need to rethink gravity itself.
Rethink gravity, like the basic laws of physics as we know them, that's pretty radical.
Right. Clegg mentioned something called MOND, modified Newtonian dynamics. Basically, it suggests that maybe gravity works a little differently on these huge cosmic scales than we thought. It's controversial, for sure.
So instead of invisible stuff, it's just that the rules are a little bendy.
In a nutshell. It's worth noting, though, these modified gravity ideas, while intriguing, aren't exactly mainstream science yet. Most cosmologists still think dark matter and dark energy are the best explanation for what we see.
So the mystery continues. Even with everything we've learned, it feels like we're still just scratching the surface of understanding these forces that shape the universe.
We are, but that's the beauty of it, right?
Oh.
Always more to learn, always more questions to answer. Who knows what amazing discoveries are just around the corner?
It's amazing, isn't it? These invisible forces shaping the universe right under our noses, and we're still trying to figure out what they are, how they work. Makes you wonder what other mysteries are still out there.
It's humbling, that's for sure. We like to think we've got it all figured out, but then the universe throws a curveball like dark matter and dark energy, and suddenly we're back to square one.
Speaking of curveballs, what does all this mean for the ultimate fate of the universe? Are we all just going to drift apart into the cosmic abyss?
Well, it all depends on this cosmic tug of war, right? If dark energy wins out, keeps pushing everything apart faster and faster. Panic actually mentions this scenario in the 4% universe.
Yeah.
Called it the Big Rip.
The big rip. Okay, that doesn't sound good. What exactly are we talking about here?
Imagine everything we know just getting torn apart, stretched to its breaking point. First, galaxies would fly apart, then stars would be ripped from their systems, then planets. Eventually, even atoms themselves wouldn't be able to hold together. Pretty bleak, huh?
Bleak is putting it mildly, so everything just unravels. Are there any other possibilities? Anything a little less apocalyptic?
Well, It's entirely possible that dark energy doesn't behave exactly how we think it does. Maybe its influence weakens over time, or maybe there are other forces at play that we haven't even discovered yet.
So the future of the universe is still a big fat question mark, could go in any direction.
Exactly. And it's a question we may not be able to answer for a long, long time, generations even. But that doesn't mean we stop looking for answers.
Right. That's the spirit. Always more to learn, always more to explore. That's what makes this whole thing so fascinating. It's like the universe is this giant puzzle, and we're just starting to put the pieces together.
And the craziest part is we have no idea what the final picture will look like. That's the beauty of scientific discovery, right? Always pushing the boundaries, always questioning what we think we know.
Exactly. And who knows, maybe one of our listeners will be the one to finally crack the code of dark matter and dark energy. Stranger things have happened.
Absolutely. That's what I love about this field. It's full of surprises,
Hmm.
and the more we learn, the more we realize just how much we don't know.
Well said. So, for all you listeners out there, keep looking up, keep asking those big questions, and never lose your sense of wonder about the universe and all its mysteries.
Because there's always something new to discover, and that's what makes it all so exciting.
Absolutely. And on that note, it's time to wrap up our deep dive into dark matter and dark energy. Until next time, keep exploring the cosmos.